Hello and welcome to our presentation. We are Sabrina and Nadya, undergraduate students majoring in computer science at Bina Nusantara University. In this session, we will present our research titled Accessible Document Interaction Through Voice, Supporting Visually Impaired Users in Human-Computer Interaction. Let's begin with a brief overview of the study through the abstract. Visually impaired users often cannot access digital documents, which are an important aspect of modern life. The study proposed a voice-based document assistance system to improve document accessibility by integrating Fauzi to convert speech to text, PyTTS X3 to convert text to speech, and large language models via LM Studio. Users can use voice commands and keyboard input to navigate, read, summarize, and ask questions in PDF and DOCX files. Overall satisfaction and good user acceptance reflected to the usability evaluation with 30 people resulted in a 67.16 score on the system usability scale, 5.84 for perceived usefulness, and 5.94 for perceived ease of use.
Individuals with visual impairments disabilities often encounter barriers when accessing digital information. Therefore, creating a technology that can grasp inclusiveness is crucial so that everyone can participate equally. One of the ways to address these challenges is to utilizing artificial intelligence, specifically large language model or LLM. The ability of LLM to understand, generate, and give human-like responses makes it beneficial for voice assistants or screen readers, helping visually impaired users to interact with technology easily. Recent studies shows many digital platforms with visual information designed without alternative text. However, alternative text is not significant between sighted and visually impaired eyes. Several existing tools for screen readers like job access with speech or non-visual desktop access have been commonly used, but a third-party technology like this often needs specific training and might be expensive. Speech-to-text and text-to-speech have been widely studied for assistive technologies with voice-driven control. The ability of STT to convert speech into text and TTS to read the written text and provide audio feedback proven to help communication between human and machine through auditory. It shows that it could be an ideal tool as they deliver contents through audio. Plus, combining it with natural language processing or NLP offers conversational capacity and contextual awareness to improve STT and TTS systems. For example, a visually impaired user can ask a question and receive relevant spoken responses with NLP, making it possible to improve e-learning navigation and comprehension. This study introduces a document reading application that integrates Fauzi for speech recognition, PyTTS X3 for speech output, and LLM via LM Studio to handle summarization and question answering. The primary goal is to create a system that can handle PDF and docs document using voice command. This technical collaboration has the potential to close the digital accessibility gap and provide visually impaired individuals with greater autonomy in the digital era.
The creation of a voice-based document assistant for the visually impaired follows the waterfall paradigm. The program is divided into modular components where the user provides input through voice, which is processed by the Fauzi speech-to-text engine to produce transcribed text. This text is then parsed by the document handling module to extract relevant content. The processed input is forwarded to a local LLM via LM Studio through API requests, where a response is generated. This response is then converted into audio using PyTTS X3 text-to-speech synthesis and played back to the user. The system is designed to run in a local terminal environment with a desktop shortcut optimized for quick access. To evaluate the user experience, we use the system usability scale, as shown in the left table, to assess general usability, and the technology acceptance model, as shown in the right table, to gain a more profound understanding of perceived utility and ease of use, and also open-ended questions to gain a user feedback. The survey used an interview approach to accommodate participants, where each question was read aloud to the participants and the responses were recorded in an online form for further analysis. The system is designed to operate in English. The interaction starts with the system prompting users to press the spacebar. Once activated, users are asked to say the file name they want to access. After successfully selecting the file, the system shows menu options, including selecting another file, reading the current file, summarizing, asking a question, or exiting the program. Most commands are performed by voice input. However, for the read a file feature, users must rely on keyboard input to navigate the pages or stop the reading, as well as give confirmation to transcribe text. The summarization and question answering features are handled by the LLM through LM Studio to generate the answer based on the selected document.
The study involves 30 participants with 13 men and 17 women, aged between 19 and 47 years. The majority, which 24 participants, were totally blind, 4 participants having low vision, and 2 being legally blind. Most participants had basic English but still needed occasional assistance during the interaction. The SUS was measured using a 5-point Likert scale, ranging from 1, 4 strongly disagree, to 5, 4 strongly agree, resulting in an average score of 67.16. And according to the standard SUS interpretation, this result falls within the marginal usability range. We also evaluate the standard deviation, resulting in score of 12.54, a minimum score of 45, a maximum score of 90, and a median of 67.5. These results suggest that the participant is able to interact with the program effectively without major usability issues. Some variation was present, the balanced distribution, and as shown in the scatter plot, there is no extreme outliers, suggesting that the consistency of user perception. In the Thumb survey, we use a 7-point Likert scale, from 1, 4 strongly disagree, to 7, 4 strongly agree. The average score of perceived usefulness is 5.84, with a score of standard deviation 0.99, and for the average score for perceived ease of use is 5.94, and standard deviation of 0.81. Although a few outliers were present in the scatter plot, most responses clustered around positive values, indicating the system was seen as useful, easy to use, and worth continuing. Responses to open-ended questions revealed that users describing the system as simple, clear, and straightforward, although some difficulties found in the microphone sensitivity, leading to inaccurate speech recognition. These findings support the effectiveness of combining STT, TTS, and LLM in enhancing accessibility for visually impaired users.
The study successfully built an offline voice-based document assistant using Fauzi for the speech-to-text, PyTTS-X3 for the text-to-speech, and a large language model to assist visually impaired users. The survey results show acceptable usability with SUS score equal 67.16 and high user satisfaction based on time score with PU equal 5.84 and POU equal 5.94, implying that the system is valuable and simple to use. User feedback from open-ended questions emphasizing the system's clear voice output, utility for understanding long text, and underlining its effectiveness and accessibility. Some challenges include the variability in satisfaction and feedback on response speed and personalization. Future work will focus on refining system performance and tailoring interaction to individual user needs, reinforcing the system potential to improve digital accessibility.
That concludes the presentation of our study and key findings. Thank you for your attention.